Hi, I'm Dilena Mendes. I'm here to discuss Unit 3 Mid-Unit Assignment. Let's look at the first question. Describe what happens to the domain and range of logarithmic function under vertical reflection. Support your explanation with diagrams. Let's use fx equals log 2x as the parent function. It will adhere to the same characteristics as the function. If x equals log ax, the vertical asymptote for the graph if x equals log ax will be the same at x equals 0. Also, this fx equals log ax function has a x-intercept of 1, 0. The domain is x belongs to a set of real numbers where x is greater than 0. Range y belongs to a set of real numbers. The entire fx equals log x should be multiplied by minus while encountering a vertical reflection. The notation of the reflection function is f, 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 f dash x. F dash x equals to minus fx minus log 2x. Fx equals log 2x. So let's now sketch the graph for the inverted function f dash x and examine how its domain and range behave in relation to. දැන් මම මේ දැන් මේකක් කරන්න යන්නේ video presentation. Let's now sketch the graph of the inverted function f dash x and examine how its domain and range behave in relation to the original function fx. So this is the graph. Y equals log 2x and y equals log 2s in here and in here. Consequently, we can say that the function fx, which is vertically reflected, have the same domain of x belonging to real numbers where x is greater than 0 and same range y belong to real numbers. In contrast of the parenting function, if x equals log 2x, there is this. No change in the domain or range aside from the sign change. Now let's look at the second question. Describe what happens to the domain and range of an algorithmic function under both horizontal and vertical translation. Support your explanation with diagrams. Let's use if x equals log 2x as the parenting function. The parenting function has a domain of x belongs to real numbers where x is greater than 0 and range is y is a real number. The horizontal translation. There are two methods to talk about the horizontal translation. One will be moving b numbers of units to the right side. The parenting function fx equals log 2x where b equals 3. The newly created function is represented by the notation f dash x. F dash x equals log 2 brackets x minus 3. Moving to right. Second one. Moving b number of units to the left side. The parenting function is fx equals log 2x where b equals 4. The newly created function is represented by the notation f double dash x. F double dash x equals log 2 brackets x plus 4. Moving to the left. Let's now examine the behavior of the domain and range in the new function f dash x and f double dash x. In the Relation to the parenting function fx. The function f dash x log 2 x brackets x minus 3. The domain will be x belong to real numbers where x is greater than 3. The range is y belongs to real numbers. The function f double dash x log 2 x plus 4. The domain is x is a real number greater than minus 4. Range is y is a real number. Accordingly, we can state domains of the two functions are different from the domains of the parent function, and the ranges of the two functions are same as the range of the parent function. This is the graph. So f dash x equals log 2 plus 4x. This is that. And then fx equals log 2x, the parenting function, f dash x log 2 brackets x minus 3. Vertical translation. There are two methods to talk about vertical translation. One, moving number of units vertically upward. The parent function fx log 2x, where a3 a equals 3. The newly created function is represented by the notation f dash x. F dash x equals log 2x plus 3. Vertically upward. 2. Moving a number of units vertically down. The parenting function fx equals log 2x. When a equals 4, the newly created function is represented by the notation f double dash x. F double dash x equals log 2x minus 4 vertically down. Let's now examine the behavior of the domain and range in the new function f dash x and f double dash x in relation to the parenting function. The function f dash x equals log x plus 3. The domain is x is a real number, x is greater than 0. Range is y is belonging to real numbers. Function f double dash x log 2x minus 4. The domain is x is a real number, x is greater than 0, and the range is y is a real number. Accordingly, we can state that both domains and the ranges of two functions are same to the domain and range of the parenting function. This is the graph. This is f double dash x. This is fx, where f dash x equals log 2 x plus 3, and this is the parenting function fx, where fx equals log 2x. This is f double dash x. F double dash x equals log 2 4 minus x minus 4. This is f dash x, y equals x, and y equals half log x minus 4. Graph the function fx minus fx 1 over 2 log x minus 4. A. Graph the line y equals x on the same rate. B. Graph the inversion function f minus x reflecting by fx in the line y equals x. Determine the domain, range, and the equation of the asymptote f inverse x. Determine the equation for f inverse x. This is the A part, f x, f dash x, y x, and y equals half log x minus 4 in the graph. This is the A part and the B part. So let's look at the third part. Let's first examine the parent function domain and range. Fx equals 1 over 2 log x minus 4. The domain will be x is a real number, x greater than 0. The range is y is a real number. We can say that with an inverse function, domain and ranges are interchangeable. Consequently, the universal function's range becomes the potent function domains, and the potent function's range becomes the inverse function's domain. Accordingly, the domain equals x is a real number, and the range equals y is a real number, y is greater than 0. We can examine the f dash x function's graphical behavior to determine the asymptote. The function f dash x has a horizontal asymptote at y equals 0 because f(x) have a large negative values when it is closer to 0. To derive the equation for the function f dash x, we must use the variable for x equals y. f(x) equals 1 over 2 over 1 log x minus 4. Y equals half log x minus 4. X equals half log y minus 4. X plus 4 equals half log y. Log y equals 2 into brackets x plus 4 brackets. Y equals 10 to the power 2 open brackets x plus 4 close brackets. F inverse x equals 10 to the power of 2 open brackets x plus 4 close brackets. So this is my explanation for Unit 3 Mid-Unit assignment. Thank you.